Okay, welcome to my video on arrays. So we'll get going. Essentially, an array, as in C#, C++, Visual Basic, is just a series of memory locations, contiguous. In other words, there's no spaces in between. It's back to back. That store multiple values that are associated with one name, unlike a scalar variable, where you have to have a separate name for every memory location. And that makes it pretty convenient for several reasons. One is you can have more flexibility, and two is you can dynamically size these things upon runtime based on some outside criteria, like how many records are in a database, where you don't have to know how big it is. You just automatically allocate it based on the number of elements that you need. So let's take a look. Okay, this is something you saw earlier in strings, because in C#, strings sort of are like a single-dimensional arrays. We're going to be looking at single and multi-dimensional arrays shortly, but let's just look at this definition I have here. A string, or an array in this case, is simply a memory location whose hexadecimal address points to the name given by the array object when it's declared by your program. Okay, so just like a scalar variable, you can have one location that has one value, but in a string it's multiple locations. Of course, they're all back to back. So really, in a sense, a string is nothing more than a single dimensional array. And you can see the index or ordinal position at element 1 or index 0, I have a T. At element 2 or index 1, I have an O and then an M. Now notice there are 3 characters or 3 elements in this array. TOM, that's 3. However, the highest index is always 1 less than the number of elements. That's a little rule you should probably try to remember. Because 0 is a number, if you count the number of digits for the index, you'll see that we have 0, 1, and 2. Well, that's 3 digits because we have 3 elements. However, since we started with 0, we won't go to 3, we go to 2. That's 1 less than the number of elements. And so it says here the memory location can contain from 0 to n characters if it's a string. It can be from 0 to n integers or doubles. Doesn't matter. It depends on what data type you declare the array to be. Further, when accessing a specific element in an array, the compiler uses a technique known as relative offset addressing. It's something that's probably not in the book, but I thought you'd want to know how that works. And the reason why I'm saying that is, if you remember our previous discussions on regular variables or scalar variables, the name on the left of the assignment operator when you're declaring and initializing the variable points to the beginning hexadecimal address of memory. That's how you have access to the contents in that memory location. Well, so does an array name. It points to that first element, that first hexadecimal address. But to get to other elements, it has to do something a little bit different, because each one of those is a different memory address. So that particular technique is called relative offset addressing, and what this means is in a scalar variable, the compiler starts at the hex address pointing to the array, by the array name. Unlike scalar variables, however, the compiler then multiplies the index specified by the number of bytes required to store each element. So, in the example below, if element 1 needs to be accessed, you'll see the element 1 up here, right here, the compiler starts at index 0, the beginning address of memory, because that's where the array name starts. That's what it points to. So it has to start right here. Okay, that's the beginning hexadecimal address of those contiguous memory locations. All right, and then it multiplies the index, which in this case would be 1. We want to go to index 1 right here to get at element 2. Is multiplied by the index number by the number of bytes required to store each element. Well, a character occupies 1 byte in memory. If it were an integer, it'd be 4, but in this case, it's just 1. So you start here, multiply 1 by 1 byte, and then add that 1 byte to the starting address. That puts us here. If it were 2 bytes, you'd multiply 2 by a byte, and you wind up over here. If it were an integer, you'd start here, and if an integer is 4 bytes, you'd multiply 1 times 4, and that would put us right here. If it were element index 2, then you start at the starting address and multiply 2 by 4 bytes, and it put us 4, 8. That put us right here, and we'd have access to that element. That's basically how it works. So let's go on to Visual Studio. And I've set up a little piece of code here we'll talk about, and I put a breakpoint there so we can see it. This is an array, and it's of type string, and that's how the compiler knows I want an array of type string. See the square brackets? That's what holds the indices. Now, there are several ways to do this. I could go in here and put 1, 2, 3, 4 in there and tell it I want 4 elements, but if you're going to go ahead and initialize it, you can leave that blank. It will know based on the number of elements that you're initializing it to. So at the 0th element, we'll have a 5. At element 1, we'll have a 10 stored. At element 2, we'll have a 15. And at element 3, we'll have a 20. Now remember that the highest index number is 1 less than the total number of elements in an array. Well, how many elements do we have? We got 1, 2, 3, 4. So if I were to ask you based on this 4-element array, what's the highest index number, you'd have to say 1 less than 4, which is 3. Okay, that's how that works. And I've just got a string output that I'm going to use. So let's go ahead and run this, and I've got a little for loop. Now, anytime you want to traverse an array, whether it be a 1- or 2-dimensional array, you're going to have to use a series of for loops. If it's a 1-dimensional array, you can use 1 loop. If it's a 2-dimensional array, you have to use 2. Okay. So let's start it, and I'm going to, obviously, we'll get to this little GUI in a minute. There's my string. I'm initializing it. Now I'm going to press F10 to go to the next line, but I want to go ahead and put this array in memory, in the watch, so we can look at it. Click on it and add watch. Now there it is. Notice it's got a little collapsible, expandable plus. If I expand that, you will see that at element 0, I've got a 5. At element 1, I've got a 10. Element 2, I've got a 15. Element 3, I've got a 20. So it actually shows you what's in that array and the elements at which the indices at which they're stored. Okay, that's 0, 1, 2, and 3. 0, 1, 2, and 3. All right, so now I'm going to step through. Now we're into this loop, and what I'm going to do is loop through the array. Now notice I've got r.length less than x less than r.length. An array has several methods. It's an object, so it has methods and properties associated with it. The length is a property of the array object. So it's going to, what the length returns is the total number of elements in the array, not the highest index. So that's why I'm saying up here x less than array length. That'll put it at 3 instead of 4. Or I could say less than or equal to array length minus 1. It just depends on what you want to do. Just remember that, though, when you're looping through, because that can cause you a source of discomfort. And then I'm incrementing x by 1. Now x is what drives the loop. That's my loop control variable. All I'm doing here is I'm saying string output, which is of type string, equals string output plus the contents of the array. So I'm going to go through every index of that array and grab that element out of there and stick them all in a string, separating them by a space. And that's what that is. That's a concatenation character, right? And then I'm going to show them with a message box. So let's go ahead and do that. All right, F10 to step through, and it's looping through the array. Now what I'm going to do is I'm going to come up here and collapse this, and I want to put string output in the watch. Right click, go to add watch, and there's string out. Notice it's got a 5 and a space in it. It got that first element up here. See that? At 0th index is 5, and notice that we start out at 0, so x, we'll go ahead and put it in there as well. When x is 0, that element contains 5. Okay, so I'm going to press it again, and we'll go to the next. See, x is now 1. As you can see in the watch window, and that condition is still true, so it's going to enter the loop, and it's going to access array index 1, which is 10. Now look what we have in our string, 5 space 10 space. So it's going to populate this is what we call traversing the array. We're walking the array from beginning to end, and now you'll see our message box. There are all the elements that were in that array, and I stuck a space in between them so you could delineate between the numbers. 5, 10, 15, 20. There they are. Okay. All right. Well, let's take a look at where we are now. This is the second little program here, and I'm going to stop this so I can run it again. Stop debugging. Let me comment out this other code here so we don't have to worry about that. You can use a multi-line comment on these little lines of code if you want to get rid of them without deleting them. Okay, so what I've got here is an array called apartments of type double. Now notice there's a little comment here. This is a 2-dimensional array, rows and columns. Now the reason I didn't put any numbers in there because I'm populating it, so it knows that there are 1, 2, 3, 4, 5 rows. And there are 2 columns per row, 1 in 500. stored at 0 index and 1 index. And for the second row, we've got 2 and 750. And now what these really represent are floor numbers and the rent associated with an apartment on a given floor. So as you go up to the penthouse level, they get more expensive because they're fancier apartments, I guess. All right, Y is driving my loop. Now I have, since I'm breaking out this loop and I'm depending on the current value of Y, I'm defining it outside of the loop so that I can have access to it. If I declared it inside the for loop, scope would only allow you to have access to it, and the lifetime of this variable would only exist while that for loop is running. After that, it's gone. It's out of memory. So I want to be able to access it when I break out of the loop. Hence, I've declared it outside of the loop scope, or the block scope. That's block scope for the loop. And I've got just a double number, which is of type double, and I'm grabbing the text out of the text box and changing it to a double and sticking it in here. And then I'm going to compare each column 0 at every row to make sure that we have a match here. They're going to give me a 1, 2, 3, 4, 5, and for all intents and purposes, we're just going to assume they give me a 1, 2, 3, 4, 5. We're not worried about data validation or error checking or anything. So let's go ahead and run this, and then we're looking up the price basically for a given floor. I'm going to use 5. Okay. So as soon as I click price, it'll fire the event associated with that button, and it will pause here at this breakpoint, and I'm going to step through. Now let me go in here and delete all of these for that old code. Clear all, and then I'm going to come in here and put apartments in there, and then I'll put Y in there just so we can kind of see what's going on. Double number, and we're going to output to the label so we can see that. All right, so F10 to continue. That populated our array right there. Watch. Two-dimensional array. See that? 0, 0 is my apartment number, 0, 1. So that's row 0, column 1. So you can think of this as a matrix, basically. All right, so that tells me that my array is populated correctly. So I'm going to step through, continue. And I'm grabbing what I typed in, which was a 5, converting it to a double, sticking it in DBL number, which 5.0 is the equivalent. Press F10. Now we're stepping through as long as Y is less than the length, the number of elements in the apartment. And also I've got this if statement here. As soon as I find a match at any particular index, I'm breaking out of this loop. And at that point I will know what row I found a match on, because we're always looking at column 0 here. That's why we have column 0. We're not looking at the price. We're just looking at this particular column here, 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 and here. Once I find a match of that column, then I'm going to come down here and use column 1, which contains all the pricing information and that particular row at which we found a match. So let's see how that works. Now I'm looping through. Since it's 5, it's going to go all the way to the last element or the highest index. That's probably it, and it is. Okay, so what was Y? Y was 4. Okay, that's where I found a match at. Notice here I put 4 column 0. I put a 5.0, so that's a match because I typed in 5. It found 5. So then you move over 1 column to the price, and all the prices are in column 1 for every row. Well, row 5. At column 1, I have $5,000, so that should be what I display. Let's see if that works out that way. There it is. The price per month for that apartment is $5,000, and you can clear it next to it. That's how you do arrays. Now, I recommend that you go ahead and code all this so you understand what's going on, and just pause the video as required so that you can get it coded and learn how to set these breakpoints and add watches. The program has to be running to add a watch. All you do is you set a breakpoint, pause it, and right-click on what you want to add, and then add to watch, and you'll have all that. That's pretty much it. Thanks for watching. Have a good day.